Okay, what we're going to do next is solve a linear system. So two lines, and we want to find out essentially where would they intersect, where would be the point of intersection. We want to use determinants. So it's called Kramer's rule. So this is our system. And we want to find out, let's say, where these two lines intersect. So we've solved systems earlier in Algebra 2 by elimination methods, substitution, or graphically and find where they intersect. This is the new method called Kramer's rule. So we're going to be taking the determinant a few times. So there are some steps on the next slide that I'm going to walk you through, and please don't get stressed out if you don't understand these steps. I have an example that we're going to go through together. Okay? So here is our system. In the blue are your coefficients. Okay? They're going to make up your determinant. So when you do step 1, you're going to find the determinant of that blue set of values. Okay? So 3 different determinants are used to find x and y. So you'll do 3 steps. The determinants in the denominator for x and y are identical. So you're going to first, in step 1, just find the determinant here in the blue. The elements of D in the determinant are the coefficients. So these are your coefficients. Then what you do next is you're going to take out some of the determinant pieces and replace them with the constants. So in the red, up here, C sub 1 and C sub 2 are constants. So in the original determinant equation, you're going to remove A sub 1 and A sub 2 and replace it with C sub 1 and C sub 2. In step 4, you're going to replace B sub 1 and B sub 2 with the constants C sub 1 and C sub 2. Okay? So here's an example. Number 1. We want to solve this equation of linear systems by Kramer's rule. So these are your constants. We will work with those values a little bit later on in our steps. We're going to work with these numbers, 5, 6, -4, and -5 in step 1. So we're going to set up our determinant matrix. So sorry, those got a little bit blue there. So we're going to sub in 5, -4, 6, and -5. And we're going to find the determinant of this 2 by 2 matrix. And I'm going to go back a few slides. We've done this already right here, where we kind of do like this butterfly method where you multiply those 2 terms together and then these 2 terms together and subtract them, and you'll get a determinant value. We're going to do that on this stuff. So we're going to multiply 5 and -5 together. Subtract 6 and -4 together. Simplify. 5 times -5 is -25. Minus 6 times -4 is -24. We have a subtraction and a negative, so that turns to a plus, and we get -1. If that determinant at that step was a 0, you would not be able to use Cramer's rule to solve this system. All right, we're going to go ahead and move on. We're going to go ahead and find the determinant of d sub x. So you're going to replace that 5 and 6 with the constants on the right side of the equation. So remember, those were your constants in red? With 5 and 6. So here's 5 and 6. Those are gone. And now you're going to replace them with 2 and 1. So 2 and 1 are your constants. And then you keep that -4 and -5. Where are the -4 and -5? Right here. Now we do the determinant again. We multiply 2 and -5 together, minus 1 and -4 together. Simplify, -10 minus -4. That becomes an addition symbol between those two terms, and you get -6. We're going to work with that -6 later on. So determinant of x equals -6. All right. Now we're going to find the determinant of y. So we write our determinant notation. We're going to replace the -4 and -5 with the constants 2 and 1. So 2 and 1 are going to go here. So if I think about this, here's my original system. I'm going to remove those terms in my determinant and then keep my 5 and 6. So keep your 5 and 6 and then replace the constants with 2 and 1. Now we're ready to go ahead and do the determinant again. So we're going to multiply 5 and 1 together, minus 2 and 6 together. Simplify, 5 times 1 is 5, minus 2 times 6 is 12, giving you -7. So the determinant of y is -7. All right, here we go. So now, to find out what our x value and y value is you're going to take the determinant of x, which is up here, -6, divided by the value of the determinant in 1, which is -1. So again, you're taking the determinant of x divided by the determinant of step 1. Simplify it and you get 6. To find y, you're taking the determinant of y divided by the determinant of d. So the determinant of y is right here, -7. The determinant in step 1 is -1. Simplify it and you get 7. So what does this mean? We solved this system. We want it as an ordered pair, x comma y, 6 comma 7. So you could check if you wanted to graph this system out and see where they intersect. They intersect at 6 comma 7. You could also plug it back into the original system and see that it holds true.